7.5 Rotations. In this section we review rotational symmetry and draw rotations of shapes. Example 1. State the order of rotational symmetry of each of the following shapes. Okay, so we look at A, and it's a diamond. I've drawn in roughly the center. Okay, so if we rotate this diamond, how many times does it make the same shape, or if any? And so when we look at this diamond, if we rotate it 90 degrees, right, if we rotate this diamond 90 degrees, then we will end up getting the same diamond. We've taken this point and rotated it over around to here. And we can go and do that again, twice. Now this has been brought all the way around here, 180. We can do it again 3 times, and we can even come back here and do it a 4th time, and then we're back to that original diamond. So for A, we say that the order is 4. Okay, we can rotate this 1, 2, 3, 4 times and get the same shape. B, we have a rectangle. If we rotate it around 90 degrees, we won't. We would have an oblong rectangle right here, so it wouldn't be the same. But if we rotate this all the way around 180 degrees, this corner would be here, and we would have the same rectangle, just upside down. And then if we did that again 180 degrees, we would come back to our original rectangle. So for B, we say the order is 2. C, we look at this shape, looks like a house. If we look at this shape and we look at, is there ever any symmetry when we rotate it, the answer is actually no. We would have to go all the way around 360 degrees to get back to that same identical shape. So we can say the order is 1, but that also means no rotational symmetry. Okay, so shape C has no rotational symmetry. Example 2. The corners of a rectangle have these coordinates, and the rectangle is to be rotated through 90 degrees clockwise about the origin. Draw the original rectangle and its position after being rotated. So I've already gone and drawn in the rectangle, and of course the origin is right here. Alright, this is the x-axis, this is the y-axis. I left off the numbers because I wanted this to be more clear, but each one here, this is 1, 2, 3, and these coordinates are in the correct spots. So we want to rotate this rectangle 90 degrees clockwise. So of course clockwise is going this direction. So we can start with these points. We can label these points. This is going to be A, B, C, and D. So we'll just have to carefully rotate these points 90 degrees about the origin, which is right here. And this can be a little bit tricky. So we're going from this point here, okay, and we have to visualize how to rotate this 90 degrees, okay? 90 degrees. Here it's at 3, 2. It's actually going to end up at 2, negative 3 when we rotate it around. Here it's at 3, 2. It's going to end up at 2, negative 3. That's going to be A prime. B, which is at 1, 2, 3, 4, 5, 6, 7, 2, is actually going to end up, if we can visualize this, it rotates all the way down here, right? A came down to here, B rotates all the way down to 2, negative 7, 3, 4, 5, 6, 7. Okay, so B prime we'll find down here. C is at 7, 5. If we can visualize rotating this thing 90 degrees, so it's going that way, it's actually going to end up at 5, 7. That's C prime. And D, which is at 3, 1, 2, 3, 4, 5, will end up at 1, 2, 3, 4, 5, and 1, 2, 3. And we probably could have got that without, because obviously this is a rectangle. But anyway, all these points, so for instance C comes around 90 degrees all the way to here, right? B does the same, D does the same, A does the same. So we can draw in our now rotated rectangle. A prime, B prime, C prime, D prime. Example 3. A triangle has corners at the points with coordinates 4, 7, 2, 7, and 4, 2. Draw the triangle. Okay, so we have the triangle here. I'll just highlight it to make it perhaps easier to see on the computer screen. This is far from perfect, but hopefully makes it easier to see. Okay, so there's the original triangle. Now, rotate this triangle through 180 degrees about the point 4, 1. Okay? So the last question we did the origin, but now we're going to rotate it around this point right here. Okay. So it shows here how if you could use some tracing paper and you hold the pencil at the point, then you could take your shape and you could sort of move that tracing paper around and then see where it went. So you could do that on your own and try it out and see what happens to the shapes when you rotate it 90 degrees or 180, 270, or any angle really. You could try 45 degrees and see where the shape goes. But the answer is illustrated here. So we're rotating about this point here, which is 4, 1. So see, you have to visualize rotating 180 degrees. So it comes from here and goes all the way around 180. Okay? And so B goes from here and goes all the way around 180. A comes from here and goes all the way around 180. So with some practice, hopefully you'll be able to visualize what's happening to these shapes. So this triangle here, once rotated 180 degrees, ends up this way. Example 4. The diagram shows triangle ABC, which is rotated through 90 degrees to give A prime, B prime, C prime. Okay, so it's already being rotated. We already know that, right? Here's the original and here's the rotated triangle. Determine the position of the center of rotation. Okay, so now we have to figure out what that center of rotation is. In the last question it was at 4, 1. Right, it was at this point here. It was given to us, and it was also given to us in the second question, and it was said to be at the origin. Okay, and it makes a difference where you rotate through, where you're holding the pencil down on that tracing paper to rotate it. We'll put the shape in a different spot, so it's important. So how do we determine where this center of rotation is? Well, we're going to try to do this here, using this. Okay, so what we want to do, maybe that one's not going to work actually. Let's use this green one. Alright, so what we do is we join a point from A to A prime, and then we want to find the middle of this line and draw another one perpendicular. Okay, so A to A prime is 1, 2, 3. There's 4 between them, so perpendicular is actually going to go just like this. Now we're going to do that with the other two. So we're going to make a line from B to B prime. Now this one's on a bit of an angle, so it's a little bit more difficult to do. Helps if you have a ruler. We're going roughly 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going just over 9 squares. And we count 1, 2, 3, 4, 5. So the center is roughly about here. Okay, so this isn't going to be perfect, but we're trying to draw a line that is perpendicular roughly to this one. So we find the center of this line, okay, and then we draw one perpendicular to that. We do the same thing with C, and I'll change up the colors here. I will use a nice pink. So C to C prime, and we need to find the center of this line, which if I click on it, actually it will show me. Okay, so it's right there. I just have to remember that. Then I'll pick the same one. We'll go from here and we try to draw a perfectly perpendicular line, and it is about like that. Now what you will see is they all cross at the same point. If we've done this well, I mean obviously we're just eyeballing it, we're doing it roughly, but you can see the one for C, you can see the one for B, and you can see the one for A, and they all go through right here. So with decent precision, we have found the position of the center of rotation.